Let's start the final part of this module on multi-criteria analysis for energy area optimization. So far, we've built a suitability map using QGIS. But there's more to the story. In this section, we'll focus on how to automatize the process, test for sensitivity to changes in weights, understanding limitations, and to validate and compare to our results to the real-world data. Manually performing weighted overlay is great for learning, but it becomes inefficient for large datasets or multiple scenarios. That's where automatization comes in. There are several ways to automate MCA and QGIS. You can use the graphical modular to build repeatable workflows, as you have seen in the last module of the course. You can use batch processing for many layers or regions using Python scripts with rasterio, NumPy or GeoPandas for full control. The graphical modular is especially useful for non-programmers and quick projects. There you can create a drag-and-drop workflow, load layers, reclassify, apply weights, and output the final raster all in one go. For more advanced automatization, Python lets you apply MCA logic to entire countries, simulate different thresholds, or even connect to web APIs like pvoo.gis or ERA5 for dynamic data loading. All this is most useful when you have to do several simulations and repeat the analysis multiple times. That brings us to the sensitivity analysis, or why weights matter. One of the most important and often overlooked parts of MCA is sensitivity analysis. This means testing how much your results depend on the weights you choose. So why is this important? Because weights are often subjective. Let's see what happens if you increase the importance of slope from 0.3 to 0.5. Or if you reduce the influence of wind speed. Sensitivity analysis helps to identify robust zones of locations that remain suitable no matter how the weights change. These areas are the most promising for real-world planning. If you validate the results with different scenarios, the results become much more robust and can be interpreted with high confidence. We also need to talk about limitations and assumptions of MCA. As powerful as MCA is, it also has limitations. You need to be aware of these to avoid overconfidence in your maps. Subjectivity in weights, unless grounded in expert inputs or formal methods, is one of the most important. Weights can introduce bias. Also, MCA intrinsically simplifies real-world problems, assuming independence between criteria. But in reality, for example, terrain and infrastructure may correlate. Then there might be data resolution mismatch. Combining 100-meter resolution wind data with coarse land use maps may distort results. Lastly, there's no uncertainty modeling. MCA gives a single value, but doesn't capture uncertainty or trade-offs. And now, finally, let's talk about validation. How do you know your suitability map is realistic? There are a few strategies. Why not compare the results to existing installations? An overlay of known wind or PV plants can show if the actual plant fall in a high suitability zone. This might be the most effective way to check the model and our assumptions. To go even a step further, expert interviews or planning guidelines can help to cross-check assumptions with policy or technical standards. Great! You've now seen a full multi-criteria analysis workflow. You've seen how to reclassify and weight spatial criteria, how to apply constraints, how to build a suitability map, and how to automate the process and make it suitable for sensitivity analysis and validation. This is a core skill in geospatial energy planning. Thank you for watching and see you in the next lesson.